All right, welcome back, PreCalculus. Hey, this is quiz 45 we're getting ready for, 14.4 to 14.5. You really have two questions, two graphs, polar graphs, and I want to go through a couple of things with you. Let's talk about your first graph. Before you can actually do the graph, there's some questions that you're going to need to answer, and I've got those up here for you. Okay, here's an equation that we're going to use just as a base equation to work the problem. You'll have one similar to this on your quiz. 2 plus 4 cosine of theta. Very first thing you want you to do is find the branch tangents, all right? Remember, that means to put in a 0 for rho. Copy down the rest of the equation, and let's use a little bit of quick algebra to solve the equation for theta, all right? So notice what's happening here is just some algebra. Eventually, we're going to get to where we can reduce. We have -1/2 equals cosine of theta. I would suggest page 64, ASTC, however you want to do that, but you'll find your answers that theta equals 120 degrees and 240 degrees. When it's time to graph, that's the first thing you should draw. You can, matter of fact, at this point, go right to the graph, draw those lines, put an arrow on them, use a straight edge, make it look good. It'll be all set. You notice that we don't have any rotation of axis in this graph, so you can put those in right away. This is probably the biggest part, a little bit of work, the symmetry part that we need to talk about. So I wanted to point out a couple of things to you. First off, in your book, page 238, figure 14E, you need to know that figure. You need to know the details in there to be able to know how to do the symmetry tests. You can't do it without knowing those things. There is a little hint on page 284, things to watch for. Sine is almost always symmetric to the 90-degree line. Cosine is always symmetric to the polar axis, and tangent is almost always symmetric to the pole. So in thinking through this problem and seeing a cosine, I'm expecting a yes right here with the poles and possibly no's with my pole and 90, but I need to go through and do that anyway. All right? To do the polar axis, the first step is to put in a negative theta. So I'm going to write the equation as normal. Rho equals 2 plus 4 cosine of negative theta. Now, according to the negative angle identities, this is an even function. Cosine is even, so the negative will come out and it will basically go away. So this equation is exactly the same. I don't need to do a second test. One test is sufficient because it gives me the exact equation. So this is a yes for polar axis. It is symmetric. That's what I was expecting. I'm expecting no's over here. Let's go ahead and run to the pole and check that one. When doing the pole, the first thing you're going to do is put in a negative for the rho. So I'll do negative rho equals 2 plus 4 cosine of theta. Now you can see from this that that negative pushed over to the other side does not go away. It changes the equation. So I have a maybe no with the first test. To run the second part of the test, I need to put in a theta plus, a 180 plus theta. And again, that's what you have to have memorized there. I'm going to double check, make sure that I'm doing it right. 2 plus 4, and then we're going to do cosine of 180 plus theta. Okay, now right off the bat, you want to take a look at ASTC. 180 plus theta is in the third quadrant. Okay, so a third quadrant angle is going to be negative for cosine because only tangent is positive there. So that is going to push a negative out front and say rho equals 2 minus 4 cosine of theta. All right, so that is a different equation. I had a potentially no up here at the beginning, and now I've confirmed it. It is not symmetric to the pole. All right, kind of what we were expecting. You do have to run both tests because you got to maybe know up top. We got to run to the theta equals 90 for our next one, and that is to put negatives in both places. So we go negative rho equals 2 plus 4 cosine of negative theta. All right. Now I'm putting that in just like we saw up here when you put the negative in, because of it being an even function, it goes away. So that is gone, but this is still hanging on. So just like we had up there, we're going to see that no, that is not symmetrical at that point. So that this is a maybe no, or we should say potentially no for that case. All right, so we need to continue our test and do it again by putting in the theta minus 180. So I'm going to go ahead and put that in. This time, remember, keep the rho, 2 plus 4 cosine of 180 minus theta, ASTC. This one is in the second quadrant. That's a terrible box, but you get it. All right, now, second quadrant, sine is positive. So again, this is negative. So that's going to push over and give me a negative angle right there. So -4, okay? this is not a negative angle identity now. All right, so that's not the same as this. This tells me second quadrant, my answer, whatever this would become, would be negative. So rho equals 2 minus 4 cosine of theta. Okay? Whatever that angle is, even the 4 will be multiplied through. The 4 can go away, but that negative will not. All right? Because we're in the second quadrant, it will be a negative answer. So no, this is not the same equation, and therefore not symmetric to the 90-degree line. Okay. At this point, there's one more question, and that is, are there any undefined values? I don't see a square on the first side. I don't see an even root on the next side, and I see no denominators. So I see nothing that's going to be undefined. There's no undefined values here in this place, okay? Now, you're ready to graph. You guys know how to do this already. You'll have your chart. You'll have a polar coordinate system, draw your branch tangents, and you're ready to go. I won't show this today. I think you guys can do that. Plot your points. Set up your grid, and then just draw a smooth curve. You'll see your shape. Thinking about the fact that it is symmetric to the polar axis in this case, I'm thinking that whatever the shape is going to go off to the right of my graph. It'll be the same on the top and bottom of that polar axis. Again, your quiz will have a different equation, but you'll do all these same steps, okay? Can you hear my daughter upstairs kind of screaming and hollering? She wants to be down here on your video. Okay, we have one more question. I'll show you kind of what that looks like in the next segment. Okay, let's take a look at the second question and a little bit different information on this one. Going to be a little easier. I forgot to mention something with the first one, so I'm going to cover it here in this second one. Here's our equation. Rho equals 4 secant of theta minus 30. Right off there, big red flag. We've got rotation of axes. Let's handle that first. All right, so what we're going to do is we're going to say alpha equals 30 degrees. We're going to go to our graph as we set this up, and we're going to set up new axes. So I'm going to 30 degrees, which would be approximately here. From the pole, make a straight line. It's got to extend down here as well, and then do a perpendicular. That'll be at 120 degrees for this one. And then this is now 0 degrees prime. Here's 90 degrees prime. Here's 180 degrees prime, and here's 270 degrees prime, okay? Those are important that you get those axes set up right now. Here's what I missed in our previous problem. You want to check for this always. We're going to do that right now. Always try to convert to rectangular and see if it's easier. Okay, so looking at my equation right here, I want to try to convert that to rectangular. I have a new equation right now. It's rho prime equals 4 secant of theta prime. Now I'm going to convert this to rectangular. Now, because I see a secant, I want to get it to its reciprocal to a cosine, all right? So I'm going to write rho prime equals 4 over cosine of theta prime, all right? So that's going to get into my possible values for x and y. I'm going to see that I can cross multiply right here and say rho prime cosine theta prime equals 4. That's an x. I recognize that from rectangular conversions. So x equals 4. Now again, in the problem we just did in the first segment, that's not going to happen. It's not that easy. It gets really complicated. You got to do it the way we've done it. But this is, I don't have to do anything. I mean, this is almost over. X equals 4 is a straight line. So I know that positive 4. So I'm going to go out here and I'm going to have a 4 maybe labeled right here. And so I'm going to just draw a straight line. I'm going to make sure that it is parallel to the 9270 axis. And that's it. That equation is done. The quiz is going to be over at that point. So you have these two questions. Again, they're similar to what we just did here, maybe a little bit different. If you have any questions, send me a text, an email. Happy to go through some more or answer some things for you. Check your book, go through the examples. They'll all be a big help to you. All right. I look forward to hearing how you're going to do.